I can turn this back in, right? Yeah. A plus.
Oh, okay.
Statistic.
We'll see. Can somebody turn off at least the one that says whiteboard? Maybe one more than that. Yeah, maybe experiment a little bit. There you go. All right. So somebody help me out. Without doing all of this, so let's see if we all can crowdsource this together. What was the lowest data point?
65.
What happened? It was okay.
What's going on?
Okay, stop.
It was in Blair.
Oh, okay, thank you. The lowest 65. What did you guys get for Q1?
71.
71?
Yeah.
Yes.
Yes. No.
Q2?
88. 82.5.
82.5. And just to make sure you guys understand, so Q1, you did 0.25 times 30. And you got 7.5, so you took the eighth number, and the eighth number in order would be 71. This one, you would take half of 30 is a whole number, 15. Whenever you come up with a whole number, you take that one and average it with the next one. I like it, so that makes sense. You got an 82.5. Q3,
88.
88. And of course the high one,
93.
93. I like it. So this is actually, everybody, there are 4 different versions of the quiz. They had slightly different samples of the numbers, but those are actual quiz grades from quiz 1.
Why would you tell me?
You guys good?
Yes.
Okay. So now you set up a scale that catches all these numbers. In fact, the scale doesn't have to have any of these numbers, but I'm going to start at 65, that makes sense. And I'm going to go up to 95, that makes sense. So let's see, maybe go by 5, 65, 70, 75, 80, 85, 90, 95. Alright. So your scale's got to be consistent. And then you just find where those data points are. So the low is 65, Q1 is 71, Q2 is 82.5, Q3 is 88, the high is 93. There you go. Cool. Okay. This next one is interesting because it's got a part C, which is sort of, there's no right answer there, just depending on the way you wanted to read these. But it all depends on, can you read these and make an argument based on what they show. The first part, everybody made too much out of it. It's just, if I know what 266 for Nike represents, and what does this 266 represent? Yeah, so what percentage is below it?
75.
So 75% below it. And how many golf balls are there?
200.
200. So 75% of 200? 150. So it's about 150 golf balls below there. I love the people that were worried about, do I include the 266? I'm thinking, I don't know if there were any golf balls that went 266 yards. That's just what the median was that they calculated. You guys, am I with me? Okay. Part B, there is some controversy, and there are a couple different ways to figure out the outliers for a box plot, for like a percentile, quartile thing. I like doing it this way, and I think it's related to something called the Tukey control chart. But the reason I like to do it this way is because it's related to what we do later when we start doing not just box plots, when we start using means and other things to figure out what the outliers are. So if I do this method, the minimum, what's the median for the Callaway?
268.5.
268.5. And if I subtract 1.5 times the interquartile range, now what did you calculate the interquartile range to be for this?
35.
Yeah, the IQR for the Callaway is 35. What's the IQR, just out of curiosity, for Nike there? 16. 216. So like somebody said, you can kind of visually verify this is true, but this is certainly less variation here than there is here. There's much more variation here, not just because of the whiskers being so far out, but because of the middle box being so stretched out. Does that make sense?
Mm-hmm.
Okay, okay. So if I go 216.5 minus 1.5 times 35, what do you guys get?
216.
216. And if I go 268.5 plus 1.5 times 35,
321.
321. So then doing it this method, I would expect to be between 216 and 321. That's where I would expect golf balls to end up. And so would 225 be an outlier in that case? No. I like it. So this part B, again, I'm not going to really use the interquartile range in this manner. Again, I just wanted to set up an idea that yes, for a certain situation we can figure out technically what is an outlier, not just subjectively. Does that make sense? Instead of, that looks like it might be an outlier, I want to have an actual way that means beyond this it's an outlier. So there are methods to do that. Now this part, the main thing I would hope to see, does anybody want to share with me their answer to part C? Yeah. What you got?
I chose Nike because I feel like for me, I want to have more truer results and be more consistent. So if I have a consistent swing, I want to be hitting a ball that's going to travel consistently.
I like it. So the reason, if you pick Nike, that is what I'm going to look for primarily, is arguing that it's more consistent. Now, who chose Callaway? Anybody want to tell me why you chose Callaway?
Distance.
You get more distance on it. So you're the guys that want to do that, get to the green fast or get way far down the I don't play golf site. Fairway, is that right? Fairway? Fairway. Okay. You're like, why did you put a golf problem on there? Because it's there. Does that make sense? This is life. So there are going to be problems that have no right answer. What I'm grading you based on with that kind of problem is, did you argue it correctly? Did you interpret the information I gave you correctly to create an argument? Does that, hopefully that makes sense. I like it. Okay, cool. So any questions on that sheet? Okay, so last thing for today. And it sounds like that means we're almost done, but the last thing is a big thing. Can you bring back up the lights for me? Let me just put you over there. Just stick on this board here. Oh, good. Got plenty of time. So to get us started, let me do some less, well, this first thing is kind of analytical, but then we'll do something a little less analytical. On quiz 1, I don't think I told you this, the average on quiz 1 was an 80.8. Yeah, that's pretty damn good. There's another number I can use that gives me more information about how my data looks. If I tell you the average, let's just make it 81. The average is 81. What could that mean? All the grades could have been 81. Are you guys with me? Then the average would have been 81. Or maybe some grades were 80 and some grades were 82. Or maybe somebody got a 0 and somebody else got a few people got 100, so it's still average. You guys, what's the main difference between those three situations I just gave? They're all 81, some are 80, some are 82s. 0 up to 100. All right, the range. I like it. Sorry, Dan. She said the one where it doesn't what now?
Me?
Yes.
Oh, it doesn't show you like the distribution.
All right, so distribution, and when you say distribution, you actually distribution.
Like if one person put the test and you got that score, then it'd still be the same as if 100 people put the all their values.
True, so it doesn't tell me the spread of the data. So here's something sort of related to that golf ball question. I know you guys know about, and I want to do like a statistical analysis on this website, Rate My Professor. You guys know about that?
Yes.
All right. Do you also know that there's another website that tells you the grade distribution for a professor? You actually have to pay money for that one, huh? But it's public domain knowledge, information. So you can go on there and see who gives the easy A's. And if you're smart, you stay the hell away from them. But unfortunately, a lot of times people don't. And then they take me next, and I'm the asshole because I want you to know shit. So you don't want an easy A. I'm sorry. It's too bad that things are set up that you do. But let's take a step back, Jeff. So let's say you go onto that website that tells you distributions of grades. And you got these two professors. They got the exact same Rate My Professor stuff. You with me? The times are the same. Everything's the same. Except, well, and the average grade they give is the same. They both give a C on average. With me so far? But one of the professors only ever goes from B to D. And let's say you're at university where a D is actually passing. Right? And right now, community college, D is no good because it doesn't transfer. Right? But once you get to university, you can make a freaking D and you've passed. Yay! Just don't build the bridge I want to use. Sorry. So one professor gives anywhere from B to D, and the other professor gives anywhere from A to F. You guys with me? Mm-hmm. So they both have the same mean. In fact, I can say they both give an average of 74.3 exactly. But one of them goes from B to D, the other one goes from A to F. What kind of student would choose the one that's B to D? Smart student. Smart about the fact that they think that they're going to do better. Well, no. The worst class I took, the one that got me so pissed off, I got the highest grade in the class and I got a B. Because this guy was waiting for some, for some god to come down, and then he was still giving them an A-, right? So, I remember this guy pissed me off so much. So, if I know I'm going to do good in the class, am I going to take the person that only gives up to a B?
No.
Shit, no. Right? So I'm going to take the person that gives A through F. I'm not concerned about the F because I know I'm going to kick ass. Now, if I'm like, oh shit, I don't know shit about this. It's Jeff in an art class. Oh God. I'm going to take the person that will, at least they don't seem to ever fail anybody. So I can get a D and keep on my way. You guys follow? So the mean is important to know, but by itself it's nowhere good enough to get a feel for the data. So I want to have two numbers that will quickly summarize my data. So I don't know what every data point is. I don't want to know that. I don't want to have 800 data points staring me in the face. I want you to give me two numbers that give me a quick feel for the data. So I want a number that tells me where the middle is, and I want a number that tells me how spread out the data is. You guys sort of with me so far? Mm-hmm. All right. So we're going to break those down one at a time. So we're going to talk about different ways to talk about the middle of data, and then we're going to talk about different ways to talk about the spread of data. We've already experienced some of these. I'm going to talk about. Where are you at? Where are you at? Let me go over there. Yeah, cool. Okay. So, for example, the mean, of course, is another name for what? Average. So this is going to be our first actual formulas in statistics. And I love it for the mean because we know how to find the mean of something. How do you find the average of a set of numbers? What do you do? In English, tell me.
You
Add them all up.
and then divide
Divided by
number.
the number. Let's say of data points. So it's not number numbers. The number numbers. Yeah. Cool. I like it. And that's in English what it is. Now math, we don't like writing that much, right? We like to be concise, efficient. We're very lazy. Frugal with our time. So what we do, and let me separate this out. So in mathish then, here's how this is represented. The Greek letter S. Oh shit. Because add them up, what's the official word for add? Sum, right? So we took the Greek letter S because we're all, math people are very creative. We want to make it look all official. So the Greek letter for S, capital S, is sigma. So what this symbol means is add them up. If it has nothing next to it, it don't mean shit. It doesn't make any sense. So it's sort of like saying, solve this. Okay, now I can do it, right? And there's got to be something in it for it to make sense. The square root of what, Jeff? So sum up what? So exactly, I love it. If I want, how do I represent all my data points? X. X represents all the values that I could use, right? Add up. Add up. And then thank God for the number of data points, I just use the letter N. This is not, I know you know how to find the average. And math is not trying to make it more difficult by setting up this. It's just trying to capture the idea efficiently. That's what math tries to do. We just have to know what the shorthand symbols mean so that I can use it. So there's two types of means. There's a population mean, and then there's a sample mean. They both have the same formula, really. It's just they have different symbols. Now this is not always true, but very often we'll use Greek letters for population things. Because it's kind of like the Super Bowl used to use Roman numerals, right? Until Super Bowl 50 came along, they didn't want it to be Super Bowl L. Boom, that's the Roman numeral for 50. Because they wanted it to be, you can drop the stone and, oh yeah, Super Bowl, so for population stuff, we want it to be like that. We want to say this is the population. So we use the Greek letter mu. It's like a letter U with an extra leg. Many of you are just going to call this an M for mean. I really can't blame you too much, but it's a U with an extra leg, and it's a French cow. Sorry. Mu, right? So that's how you pronounce it, mu. And so that would equal sum of x over n. I think the book makes the n capital because it's a population, but screw it. N is just the number you got. The symbol I use for sample mean is going to be our letters. And it's not going to be just x, it's going to be x bar. So if you see x bar somewhere, that means the sample mean. Mu means the population mean. I like it. Yes, sir.
So the mean and the population mean, in the example you use, the population mean is the exact same thing as the mean just applied to the entire population.
So I use this letter to make sure that people know that I have a population.
Right, but the thing that you wrote at the top is just, that's the formula for it?
Yeah, that's the idea of a mean anywhere.
And then the difference of the population mean and the sample mean
Is just the letter, the symbol we
what
use.
x is big.
It's just the symbol we use.
Okay.
Yeah. So they both have the same formula, don't they? They have this formula, because that's how you find the mean of anything. But I use that letter if it's population, and this letter if it's a sample. I like it. So if you see somewhere written mu equals 11.7, yeah, they have the entire, somehow they know the entire population, and they know it's 11.7. So, and if it was x bar, it's just the sample bar. They didn't have the whole population to work with. Yes, sir. Yes, sir.
How would you figure it out if they don't have like a certain population number? It's just all the population and a specific number. You just use the symbol?
Well, if you have the data to work with, you have to know how many data points there are.
But like, you know how like some problems it just says like all of the population or like all of the patients in the hospitals. If you don't know the exact number of the population.
They'll give it to us in problems.
Yeah, there would be nothing. I would use this letter to symbolize the mean of all the patients, but they have to give you some way to calculate it. I mean, that would be the letter, the symbol I would use for it.
There always has to be a number to the population.
Yeah, otherwise you can't figure out what it is. So I think you're worried about the fact that we sometimes just say the population of Florida. All right, well, I can go down, I can figure out how many freaking people are in Florida, right? There's got to be a way to do that. I have to get all the data points, and then that means I know how many data points there are. If I have a whole population to work with. So I want to work with all the students at Grossmont. I can go to the admissions and get information about every student at Grossmont, and I can know exactly the number of students at Grossmont. That would be the population amounts, right? And then I can figure out the population mean. Or if I go out and take a random sample of 28 Grossmont students, I would use this symbol to represent what I find. I like it. So the mean is one thing. Let me ask you this. If you use so why are there other ways to calculate the center of data? Because the mean is sometimes misleading itself. If I want to know how much does it cost to live in La Jolla, now there are houses in La Jolla that cost millions, but there are places in La Jolla that don't cost that much, right? So if you told somebody the average of the cost of all the houses in La Jolla, why might that not be the accurate way to represent it?
Because the prices would be skewed towards the more expensive side.
The larger numbers that are in the data would pull that average up. So I need to have a different way to find the middle of data. So let me give us a smaller set of data to work with. Let's say somebody's about to start work at this company, and people make. Let's say there's 4 people at this company. There's a guy that makes $28,000 a year. There's a guy that makes $34,000 a year. Another guy who's been there for a while makes $42,000 a year, and then we got the CEO that makes $350,000 a year. If you wanted to give this person an idea of how much money to expect to make, would you tell them the average salary? No, because again, the large number would pull that average up. The mean is affected by, what would you call this? Even by sight, I can tell that's an outlier, right? Later we'll have ways to figure out exactly what makes it an outlier, but that's pretty much obviously an outlier. So there's a better thing to use. We've already figured this out before. What's the way to find the middle of a set of data? The true middle, not the middle value, but the middle position. No. See, the average is the middle in terms of the values of the data. I want to know what's in the middle. Yeah, Q2, which is also called the P50, which is the median. And the symbol for the median is, it's a mean that had a rough night, so it's got a bent, or a good night, I don't know. Depends on your... Yeah, exactly. So somebody help me out. What's the average of those numbers? So let me set this up a little bit. So what's the sum of X?
454.
What do you get? 450? Let's see, 76, 104, 454, yeah, right? Cool. And so what's the mean going to be?
113.
454 divided by 4, 113.5? Okay. So if you tell them $113,500, that's insane. They're not going to expect to make that. But what's the median of this set of data?
34.
What's in the middle of 34 and 42? How far apart are these? 8. Half of 8 is 4. Added to 34, 38. I like it. Now, if I tell them 38,000, that's a much more accurate picture. So, when do you think median is very often better to use than mean when your data has outliers? I like it. How are we doing there? Doesn't mean the mean doesn't mean anything. It doesn't mean the mean is not useful for anything. It just means in this situation, telling somebody what they could expect to make, I'd want to use the median. If you ever read, you know that newspapers still exist, or if you ever watch TV and they always talk about the median house price in San Diego. They always talk about the median salaries. They always talk about those situations. That median is a better sense of the heartland of the data, right? All right, maybe. Okay. So we got mean, we got median. These both work with what kind of data? Qualitative or quantitative? Oh, sorry.
What's the symbol?
Quantitative.
For median?
Say again?
What's the symbol for median?
Oh, you would say this is X tilde. Right, that's a tilde? How do you want to pronounce it? X tilde, tilde? Or you just say median. But this one we call this, what do you think we're going to call this? X bar. Yeah.
Are we going to need to know that, as long as we know the symbols, is that enough?
Yeah, you're good. Yep. All right. Wait a minute. Okay, so we got mean, we have median. And median, we already know the formula or the process because it's just Q2. We already know how to find that. And they both work for quantitative data. So this next measure center actually works for qualitative data as well. And it's something called the mode. I was thinking about ice cream. I want some ice cream. And some apple pie. So the mode is the data point that occurs the most. I love it. So mode most. So for example, so it's the data point or points occurring most frequently. Become the word most. There. All right. So a really easy example: 1, 2, 2, 4. What's the mode? That's amazing. What about 1, 1, 2, 2, 4? 1 and 2. 1 and 2. So it is bimodal. I like it. And then you can have trimodal. Normally after trimodal, you just go, there's no mode. It's like 4 modes, there's no mode. It's like 4 centers. No. So the reason I said it works for, let me see, one more example. So make sure you guys see. What if I had 1, 1, 1, 2, 2, 4?
1.
Yeah, there's a winner. 1 is the winner. It's the mode. Don't say, well, there's 2 2s. No, there's 3 1s. It won. Right? Here's a tie. Here, there's the winner is 1. Let that make a lot of sense. Way to go, Jeff. Mood. Yes?
So what if you had, let's say, 3 or 4 of the same, how would you choose which one to pick? If you say there's not tri or...
No, trimodal I'm okay with.
Okay.
Beyond that, and again, this is another place where people disagree, but beyond that, normally we just say there's no mode. There's no place.
Oh, I
so
see.
The mode is an idea of trying to see
Yes.
where do things seem to be clustering.
Okay.
Is there somewhere where the data is clustering? That's another way to think about the center of the data. And then just an example of qualitative data. Let's say you went out to the parking lot. That's the word. And you saw that there were 11 Fords and become the word Chevy. 14 Chevys and there was 2 BMWs and then oh, there's a Pinto out there. Just stay away from that. Oh, blah blah blah. Whatever. What would the mode be? Chevy. Okay, good. So it works for. So my data is names of cars. So the mode here is Chevy because it occurs the most. So mode is nice. It's like I can work with numbers or non-numbers. Obviously, you can't average non-numerical data. I like it. Maybe.
Is there a symbol for mode?
No. We could make one up.
No, it's okay.
No? Okay.
No.
So just use the word mode for mode. Right? Okay. So we got mean, median, mode. And then there's one more I want to talk about. I don't think I'm missing anybody. No. Yeah, okay. There's one more, and it's called the mid-range. Now we know what the range is. What's the range? Yeah, high minus low. So what do you think the mid-range is? It's the number that's in the middle of the range. So here's what sucks though. Range is high minus low, because I want to see how far to go to get across the whole set of data. Mid-range, what are you going to do with the high and the low to figure out the middle? You're going to, how do you find the middle of any two numbers? You take the average. After you add them together. Oh shit, you see what I'm saying? So range is high minus low. Mid-range is high plus low divided by 2. It's the middle of the range. The name tells you what to do. It's crazy. I can't, please don't let that be difficult, right? So, you know, what's the mid-range of that data?
7.2, 6.2, 6.5. There we go.
There you go. 12 plus 1 divided by 2. 13 divided by 2 is 6.5. I like it. What's the median?
5.5.
Good. 5.5, right? So I agree with people back there. If you have a very small set of data, you can pretty much just cut it in half visually. You don't have to really do much work. So it's going to